Okay, so one of the things that we need to be able to do in order to actually figure out a chemical formula is we need to look at percent compositions. Now I'm talking about experimentally determining, not just your typical, look it up or whatever, but actually to experimentally determine what the formula is for an unknown compound, we have to look at percentages. So we're going to kind of run this backwards from how we do it in the lab. In the lab, we would do an experiment. We would calculate what percent of our results are each different element, and then we would use those percentages to write an empirical formula, and then use our masses to do a molecular formula. Here, we're going to kind of roll that back the other way. We're going to start with a molecular formula, and we're going to calculate the percent composition. So for this video, you are going to need a calculator. You are going to need your periodic table, and probably also your pink chart so that you can look up polyatomics, because we're going to have to write some formulas again. All right, so if we wanted to calculate the percentage of girls in the class, what would we do? Well, we would count. Ooh, that's very, very thick. Let's try a smaller. Boop, there we go. So we would count the total number of students then we would count just the girls. And then the calculation we would run to find a percentage is always part, so that would be the girls, divided by the whole, that would be the total class, times 100. Okay, and that would give us the percentage of girls in class. So when we're doing this for a compound, we look at the mass of the element, because this is percent by mass, divided by the molar mass of the compound times 100. Okay, now, really important, mass of the element, make sure you take into account how many of that element you have. If you have 6 carbons, you're going to use the mass of carbon, 12.011, but you are also going to need to multiply that by 6 because you have 6 of those. Okay, so let's do this first example. I'm going to zoom in on it real quick, so we got lots of space to work on here. Beautiful. So it says to calculate the percent composition of just sulfur in aluminum sulfite. So this is where we're going to need our charts to look up aluminum sulfite. So aluminum, of course, we know is Al. Sulfite, ITE, means it's polyatomic, so that's going to be SO3. Oops, I said SO3 and then I wrote SO4. Goofy me. Sorry. So it should be SO3. We know that the charge of aluminum from the periodic table is 3+, so that would go over here on the sulfite. And then we know the charge on sulfite is 2-, so that 2 would go on the aluminum. Okay, so first of all, we need the molar mass of aluminum sulfite. So we're going to start by getting the molar mass. And remember that to do the molar mass, we're going to take the mass of each compound, or each element in the compound, and add them all together. So we have 2 times the mass of aluminum, which is 26.982, plus 3 times the mass of sulfur, which we know to be 32.066, plus 3 times 3 would be 9, so we have 9 total oxygens. So 9 times the mass of oxygen, which is 15.999. So that's going to give us a molar mass for this compound of 294.153 grams per mole. Okay? The next thing we're going to do is we're going to take the mass of just the sulfur, because that's just what we want. And we've got 3 sulfur times the mass of sulfur, which is 32.066. And that's grams per mole of sulfur, divided by our molar mass of the compound, which was 294.153 grams per mole, and then times 100. Now, real quick, before we get too excited here, let's look at what our units do. Grams per mole cancel with grams per mole. So my units are not going to be in grams, they're not going to be in moles, they're not going to be in grams per mole. It's going to be a percentage. So we have 3 times 32.066. Divide that by 294.153 times 100. That should get you a percentage of 32.7033895. On these ones, because we're using molar masses off the periodic table, we're not going to do sig figs because sig figs require that we have a measurement rather than a constant. So we're going to just say round to the hundredths place. So we're going to call this 32.70% sulfur. Okay? So let's do another example. Now this time, instead of just asking for a single element, they want every single element in tin 4-phosphate. So let's start with simply the formula. Is the first element a metal? Yes. Tin is Sn. Is there a Roman numeral? Yes, there is. There's a 4. So that is the charge of the tin. Tin has a 4 plus charge in this case. Does the second word end in IDE? No, it doesn't. It's ATE, so that's a polyatomic. So we're going to go to our polyatomics chart, look up phosphate. We should get that that is PO4 with a 3 minus charge. Okay? Then we are going to take the 4 from tin, put that on the phosphate. The 3 from phosphate, that goes on the tin. So let's get the molar mass of this. We have 3 times the mass of tin, which is 118.711, plus 4 times the mass of phosphorus, which is 30.974, plus the mass of oxygen. 4 times 4 is 16, times the mass of oxygen, which is 15.999. This gets us a molar mass of 736.013 grams per mole. All right, so they asked us to do each element. So for tin, we have 3 times the mass of tin, which was 118.711, divided by the molar mass, which was 736.013, times 100. So 3 times 118.711 divided by 736.013 times 100. 48.3, round to the hundredth place, 48.39% tin. All right, so then let's do phosphorus. We have 4 times the mass of phosphorus, which was 30.974, divided by the molar mass of our compound, which was 736.013. This is grams per mole. This is grams per mole, times 100. So in our calculator, 4 times 30.974 divided by 736.013 times 100. Rounding to the hundredths place, that should be 16.83% phosphorus. And I'll do the oxygen up here. Okay, for the oxygen we had 16 times the mass of oxygen, which was 15.999, divided by our molar mass of the compound, which was 736.013. This is grams per mole. This is grams per mole, times 100. Sorry, that is very hard to read. That is a 16. Excuse me. 16 times 15.999 divided by 736.013 times 100, 34.78% oxygen. All right, so that's percent composition. And it's often called percent by mass or something of that nature. So please do the rest of the problems on the worksheet.